Hey everyone, Teacher Chang here, and today we're going to take a look at a piecewise functions in a real world situation. So in this particular scenario, we're going to take a look at a couple of bike lovers and how they are traveling along their bike ride. So here's the scenario. Michelle and Rasheed love going on long bike rides. Every Saturday, they have a particular route they bike together that takes 4 hours. Below is a piecewise function that estimates the total distance, d of t, in miles they travel in t hours during their bike ride. So let's go ahead and investigate this a little bit more. So the first thing that we notice is that we're comparing two things. The first thing that we're comparing is the total distance, which is measured in terms of miles, and represented by d of t. And the second variable that we have here is our time, which is measured in t hours. Now, if we look at our piecewise function, we can see that it's broken up into 4 parts. Now, the first part is going to be between the 0 and the first hour. The second part will be between the time is between the first and the second hour. The third part is when the time is between the second and the third hour. And the last part is when the time is between the third and the fourth hour. Now, we're going to use this information to help us answer some questions here. So let's go ahead and take a look at some of these questions. Okay, so for the first one, it's asking us what part of the bike ride do they go the fastest, the slowest, and how do we know? Well, before I answer that question, I'm going to look at my equations here, the 4 pieces here. And what I notice is that they're written in point slope form, which means that if I rearranged it and set it equal to y, it's going to look like y is equal to m times x minus x1 plus y1. So we can see all of our information here. And from here, we can tell that our slope is going to be in front of the parentheses, and the x1 and the y1 will be some given point within time. Now, the question, once again, is asking us, well, when are they moving the fastest and when are they moving the slowest? Well, to figure out, well, how fast and how slow these bikers are going, we need to figure out, well, what is their rate? What is the rate of speed or the rate of change? Now, rate in this particular case is going to be measured by the total distance over time. And well, that is basically the slope. So it's the total distance over some given time. Now, when we take a look at our slope, we're actually looking at the absolute value of our slope because our speed is going to remain the same whether we're traveling forward or if we're traveling backwards. Now, if I take a look at each of my slopes, I can tell, well, which one's the fastest and which one's the slowest. Now, the fastest one is going to be where the slope, where it's going to be the greatest value, and that's going to be the largest slope or the steepest slope, and that's going to be in the first hour. So within the first hour, they're traveling at the fastest rate or at the fastest speed. So here, the first hour is going to be the fastest. Now, the part that they are traveling at the slowest rate, that's going to be the one with the smallest slope. So if we take a look where the smallest slope is right over here in the second hour. So during the second hour, they're traveling the slowest. Okay, so that's how we figure out, well, how fast or how slow somebody is traveling within the scenario. We're taking a look at their rate, which is the same thing as their slope. And the greater the slope, the faster they're moving. The lower the slope, the slower they are moving. All right, the second part is our domain. So the domain is basically when we're looking at our x values. In this case, we're looking at our t values, which is time. So it is measuring from the beginning to the end of time. And the beginning of our time is at 0, and the end of our time is 4. So they traveled or they biked a total of 4 hours. So the beginning is 0 hours and the end is 4 hours. So between 0 and 4, and you can write it in terms of brackets, or you can go ahead and write it in terms of inequalities. So our time is between 0 and 4 hours, and it does include the 0 and it does include the 4. Okay, so the domain is based off of our time. This next question, question number 3. It's asking, what is d of 2? And explain what does that mean. Well, that 2 is our t value. Because remember, this is d of t. So t is going to be 2 hours. Now what I want to do is I want to figure out, okay, which of these 4 equations are we going to use if t is equal to 2? Well, that's going to be this second one because t is going to be less than or equal to 2, whereas in the third one, that t is greater than 2. So it's not equal to 2. So I'm going to take that 2 and I'm going to substitute it into this equation. So if I substitute it in, it's now going to say d of 2 is now equal to 6 times 2 minus 1 plus 16. Well, 2 minus 1 is just 1, and 6 times 1 is 6, and 6 plus 16 is equal to 22. So now we have d of 2 is equal to 22. Now that's our notation form, our function notation, and we want to know, okay, well, what does that mean in the context of the problem? Well, remember, d of t represents how many miles they traveled. So the 22 tells us how many miles they traveled, and the 2 represents the time. So it's basically telling us after 2 hours, they have traveled a total of 22 miles. So they have traveled 22 miles. So that's what it means in the context of the problem. All right, the next piece we have here is how far have they traveled at 3 hours? And then we want to write our answer using function notation. So the piece here is that, well, t in this case is equal to 3. Now, if t is equal to 3, I want to solve for d of 3. So I'm going to look for where is 3? Where is our 3 in our 4 pieces here? Well, our time is going to be 3 in the third piece because that's t is less than or equal to 3. So that means I'm going to use this equation. So when I see a t, I'm going to substitute that with our 3. So that means 14 times 3 minus 2 plus 22. And 3 minus 2 is 1, and 14 times 1 is 14, and we add that to 22, and we get 36. So the function notation in this particular case is d of 3 is equal to 36. Now, if we were to write out what that means in the context of the problem, that just means in 3 hours, they traveled a total of 36 miles. And then the next piece right here is asking, well, what is the total distance they've traveled on this bike ride? Well, we need to ask ourselves, okay, well, when did they end their bike ride? Well, they ended their bike ride at the 4th hour. So after 4 hours, we're going to end the bike ride, and that's going to tell us how far they've traveled. So what we're going to do is we're going to look for d of 4. So d of 4 is going to be this last equation here. So t is less than or equal to 4. So I'm going to use that last equation. So 8 times t, and in this case t is 4. Oops, don't close that parentheses yet. We have 4 minus 3 plus 36. Okay, so now I have my equation. I'm just going to solve it. Well, 4 minus 3 is 1. 8 times 1 is 8. And 8 plus 36 is going to give me 44 miles. So they traveled a total of 44 miles throughout their 4-hour bike ride. All right, now what we want to do is we're going to take this information and we're going to graph it. So we want to sketch a graph of this function. So how do we sketch our piecewise function? Now remember, I'm going to write out our point-slope form. Our point-slope form is y is equal to m times x minus x1 plus y1. Now why did I do this? Well, because we need to know, well, what is our slope? Well, our slope is that number in the front of our x. So it's in front of our x minus x1. Now the x1 and the y1 is going to represent a point. So this is a point on the line. Okay, so now that we have that point on the line and we have a slope, we can go ahead and graph each of these pieces. Now our x values is basically our time, and that time is measured in hours. And the y values is going to be the total distance. So the total distance, and that is measured in miles. Okay, so what we're going to do is we're going to graph each of these little by little. I'm going to start off with this first one in green. Now, we can see that this is occurring along the intervals of 0 to 1 hour. So let me go ahead and change that. So it's between 0 and 1 hours. So I'm going to go ahead and just graph that between 0 and 1. That's all I'm going to do. I'm just graphing this line between 0 and 1. Well, we can also look at this particular equation as y is equal to 16 times t minus 0 plus 0. And that 0, those two zeros, is basically our starting point. Okay, so that's our point on the line. So starting at 0, 0, when the time is 0, well, they haven't traveled anywhere. Now, they did have that slope of 16. Now, that 16 means 16 over 1. So I'm going to go up 16. So I'm going to travel up 16 all the way up here, and I'm going to go over 1. Now, you got to look at your scale, because 1 is not just one step to the right, but it's actually 2, because we have to go 1 hour. So we got to take a look at the scale of our graph here. So that's going to be the first piece of our graph, and I'm just going to take my straight edge, and I'm just going to connect those 2 points, and this is what that first part of our graph is going to look like. Okay, so now I'm going to take a look at the second part of our graph. The second part of our graph I'm going to do in purple. Okay, now the second part of our graph, notice that it starts at this point. So the point is our x1 and our y1, and that's going to be our starting point, and that point is at 1, 16. Now, why is it a positive 1 and not a negative 1? Well, it's a positive 1 because, and I'm going to highlight this, because of this minus sign. Because if we did a minus 1, well, that means we're doing a minus our x1, and x1 is our point, so at 1. So now we have our first point at 116, which is right over here, and the slope is positive 6. So that's going to go over up 6 and over 1. Now remember, we got to take a look at our interval, and our interval is between 0 and 2. Let me change that color to purple here so that we have everything matched up. So it's between 1 and 2. So that means I'm only graphing this line between 1 and 2. So again, I'm starting at my point at 116. The slope is 6, so I'm going to go up 6 and over 1. Again, we got to take a look at our scale here to see, well, where is 6 and where is 1? So I go up 6 and over 1, and then I take out my straight edge, and now I'm going to connect those 2 points. So that's what the line looks like in the second piece of our graph. Now let's go ahead and take a look at the third piece of our graph. The third piece is between the hours of 2 and 3. So during the second and third hour, between the second and third hour, that's where our third piece is going to be. And notice, once again, the point that it's starting off is at 2:22. And at 2:22, well, if you haven't noticed, it happens to be the point where we left off, because it's a continuous graph. Our graph is not going to jump because they're going on a bike ride, so they're not jumping from one point to the next. So it's a continuous graph, so we're picking up where we left off, and the slope in this particular case is 14. So that means I'm going to go up 14 and then over 1. So if I go up 14, okay, and then over 1, there's our next point, and we're taking our straight edge. We'll go ahead and connect those 2 points, and that piece is going to look like this. Okay, now we have our final piece. Now our final piece here is between the third and the fourth hour. So between the third and the fourth hour, it's going to be between here and here. I'm going to draw that last line, that last piece. And during that time, we can see that it's starting at 3 and 36. So it starts at 3:36, which is where we left off, right over here. And then the slope is 8, so we're going to go up 8 and over 1. So 2, 4, 6, 8, and then over 1. and here's our ending point. And again, we'll take our straight edge and we'll just connect those 2 points. And remember, we said earlier that they traveled a total of 44 miles. And we could see that when we ended at 44 miles. So that's a quick little check to see, well, where are we ending? Now, when I go ahead and wrap up my graph here, I'm going to go ahead and get rid of all of these lines here. And this is basically what we have in terms of our graph. So this is what our graph should look like within the 4 pieces. So the first hour, we could see that it has the steepest slope, which means it's traveling at the fastest rate. And then in the second piece, we can see that it's a little bit more flat compared to the others, and therefore it is going at the slowest rate. All right, let's take a look at this next situation here. In this next situation, we still have our bike ride, but this time it's only Rasheed. Now, Rasheed also has a route that he likes to take on his own and has the following continuous piecewise function to represent the average distance in miles he travels in minutes. So this is slightly different because if we take a look at how we're measuring things, the distance, d of t, is still measured in miles, but this time the time is measured in minutes. So our time is in minutes. So here's our piecewise function. Again, we have 4 pieces, 4 parts. So when we eventually graph this, we'll take a look at all 4 parts. But before we do that, we should be able to answer some questions. So just like before, we want to figure out, okay, well, what is the domain? What is the domain of this function here? Now, remember, the domain is our beginning and our end. Well, the beginning of Rasheed's bike ride is 0 minutes, and the end is at 100 minutes. So we're starting at 0 minutes and we're ending at 100 minutes. So we have these brackets, or again, you can put it in inequalities. But basically, this is telling us that he's biked for a total time of 100 minutes. So there's a total time of 100 minutes in his bike ride. Okay. Now, we also want to know, okay, what is the average rate of change? Now, remember, we stated earlier that the average rate of change is our slope. Okay, so this is our slope. And we want to know, well, what is that average rate of change between the intervals of 20 and 50? So between 20 and 50 minutes is where we're looking at. So that's right over here, between 20 and 50 minutes. Well, that means our slope is going to be located right over here at 1/5. Well, remember, it is a change in our distance, so that's our miles, over our time, which is in minutes. So that average rate of change is 1 mile for every 5 minutes. Now, you could go ahead and leave it like this at 1 mile for every 5 minutes, or we could go ahead and rewrite that as about 0.2 miles per minute. So this is the same thing. If you divide 1 divided by 5, we're going to get about 0.2 miles per minute. Okay, so 2 ways we can write it out. All right, now if we take a look at number 9, it says, over which time interval will have the greatest average rate of change? So we want to know which one has the largest slope, the greatest average rate of change. So if we take a look at each of our slopes here, you could either try to compare them in terms of these fractions, while others, you may want to change it into decimal form. And if you change it into decimal form, the largest value will go ahead and show you, well, which one has the greatest slope. So this first one, well, 1/4 is 0.25. 1/5 is 0.2. 2/7 is just around that 0.29 mark. And 1/8 is at the 0.125. So the largest slope in this particular case is going to be that third piece here. So this third piece is our largest slope, which means it is between the minutes of 50 and 92. So between 50 and 92 minutes, we have the largest slope, or the greatest average rate of change, of 0.29 miles per minute. All right, let's take a look at number 10. It says to complete each statement, then describe what the statement means in the context of the problem. Now I'm going to do number 10 and 11 at the same time, because on part 11, it's asking us, well, how did you determine the function values in number 10? And that's just basically showing your work. So let's go ahead and do that really quickly. I'm going to go ahead and take a look at D of 30. Now D of 30 means that I'm looking at the 30-minute mark. So if I look at the 30-minute mark, well, 30 is going to be inside that second interval. So we're going to go ahead and take a look at that second interval, because 30 is between 20 and 50. So I'm going to go ahead and copy that equation, but anytime I see a t, I'm going to replace it with that 30. So 30 minus 20 plus 5. Okay, well, 30 minus 20 is 10, and 1/5 of 10 is 2, and 2 plus 5 is 7. So that means D of 30 is equal to 7. Now, what does that mean? Well, that means 30 minutes. In 30 minutes, he traveled 7 miles. Okay. D of 64. Okay, so D of 64. That means when t is equal to 64, I'm going to look for that interval. And that interval is in this third piece right here. 64 is between 50 and 92. So I'm going to do D of 64. And I'm going to copy that equation, so 2 over 7. But when I see that t, I'm going to replace it with 64 minus 50 plus 11. Okay, well, 64 minus 50 is 14, times 2 is 28, divided by 7 is 4, and then add 11, and that's going to give us 15. So D of 64 is 15. All you do is the math here, and now what that means is that in 64 minutes, he traveled 15 miles. Okay, and then finally, we have our D of 10. Now, D of 10 is going to be this piece over here between the 0 and 20-minute mark. So 10 is between 0 and 20. And we're just going to go ahead and substitute that t value with 10. So we want 1/4 of 10. And that ends up being 2.5. So D of 10 is equal to 2.5. And that means for 10 minutes, he traveled a total of 2.5 miles. Okay, so now let's take a look at this last piece here, number 12, and I moved this piecewise function down so that we could see it a little bit better. Well, what we want to do is we want to figure out, well, what are the values of A and B? So if you take a look at our piecewise function, if you didn't notice, our last piece, instead of a number here, we have A and B, two missing variables. And that's what we want to figure out. So I typically ask my students to investigate what's going on here, if they see any patterns here. And one of the first things that my students typically notice is that, well, we have a pattern here. We got 20 and 20. We got 50 and then 50. We got 92, which means A is 92. Now, why is that happening? Well, it's happening here because this is a continuous function, meaning that it's continuing off from the last piece. So since it's continuing off from the last piece, what we want to do is we want to figure out, well, what is this B value? And to figure out what that B value is, I'm going to go to my last piece because they both have that 92. So what I'm going to do is I'm going to go ahead and figure out, well, what is D of 92? Well, D of 92, well, since they're in both pieces, I could put it into this previous piece, this previous part of our function here. So that's going to be 2 over 7, and then we have 92 minus 50, and then we have plus 11. So now all we got to do is the math here. Okay, so once we do the math, this piece right over here, 92 minus 50, multiply that by 2/7, that ends up being 12. And, well, 12 plus 11 is going to give us 26. So B is equal to 26. So now we know what A and B are. So A is 92 and B is 26. And now we can go ahead and graph our piecewise function. So this is the last part that we're going to do here is we're going to graph this function. Now, I'm going to go ahead and put in our A value. A we said was going to be 92 and B is 26. So I'm going to put that right here. So 92 and 26 for A and B. Okay, so we're going to go ahead and graph this, and like before, we got to label our axes here, and the x-axis is going to be our time in minutes. Okay, so this is our time, and our y-axis is our distance in miles. Okay, now I'm going to take a look at my intervals, and our first interval is between 0 and 20 minutes. So that's going to be a line from here to here. Now if I take a look at my scale for my time is counting by twos, but we only labeled every 10. And my y-axis is also counting by twos. And this time we did label each one. So since they're both using the same scale, I can count these little squares when I use my slope. So I just want to keep that in mind when we go ahead and graph these. Okay, so let's take a look at this first one. We have our first one where the slope is 1/4 and well, our time is 0, and that means our distance is 0. So that means I'm going up 1 and over 4, which is this piece over here. So I go up 1 and over 4 and so on. And again, the reason why I could do this is because they're using the same exact scale. Otherwise, I actually have to look at the numbers. Now, I'm going to continue to do this up until the end of our point. Now, if I actually, here's a little trick, is that, remember, it's a continuous function, which means I'm going to end on my next piece. So my next piece, the point is at 20 and 5. So if I go over to 20 and 5, which is right over here, well, that means that's going to be the end of my first piece and the beginning of our second piece. And if I actually continue my slope, you'll see that. So if I go up 1 and over 4, and then that's my next part, and then up 1 and over 4. Well, that's up here, but I gotta go halfway because I'm not going all the way across. So this is the first piece of my line. I'll take my straight edge, I'll connect that first part here. And now I'm going to move on to my second piece. And again, because I know that this is a continuous function here, what I'm going to do is I'm going to go ahead and look at the next point. So this next section, I'm going to go ahead and do it in, let's do this purple color here. This is between the 20 and 50 minute mark. So between 20 and 50 minutes. And I could see that we're starting off at that same point at 20, 5. And if I take a look at my next piece, that's where I'm going to end. I'm going to end at 50, 11. So at 50, 11, here's 50. 11 is right over here. That's where I'm going to end. So I'm going to go ahead and take my straight edge, and I'm just going to connect these two pieces here. Oops. Let me erase that really quickly. Okay. So let's move this. And we're just going to connect those 2 points. And that's going to represent our second interval. So our second interval is from here to here. Now our third interval, or our third piece, is going to be right over here between the 50 and the 92 mark. So between 50 and 92. So from here all the way over here. And again, what I'm going to do is I'm going to go ahead and take a look at where we're starting. Well, we're starting at that 50 and 11, and we're going to end, so here's my 50 and my 11, and we're going to end at the 92 and 26. So I'm going to go ahead and go to 92, and I'm going to go all the way up to 26, and that's going to be right over here. So I'll draw that straight line. And the last piece, which I'll do in red, well, that one we actually have to look at the slope again. Let me get rid of this right over here. Okay. All right, so let's take a look at that last piece. And that's between 92 and 100 minutes. Well, between 92 and 100 minutes is the rest of my graph here. And we could see the slope is 1 over 8. So that means I'm going to go up 1 and over 8. But I can't fit that in. Up 1 and over 8 is going to be somewhere out here. Okay, so I'm going to cut it in half. So I'm going to go up a half. Or if I actually go up 1 by the scale, here's 1. And then over 8, 2, 4, 6, 8, that's right over here. So this is where I'm ending. And we'll connect those 2 points. And there's my graph. Now, I'm going to go ahead and erase all of these dotted lines where I use my slope. But this is basically what your graph looks like in terms of your piecewise function. Okay, so we have broken it up into 4 parts. I'll put that first piece back in. So the first part is between 0 and 20 minutes. The second piece is 20 to 50 minutes. Then we have 50 to 92 minutes, and then 92 to 100 minutes. All right, so that's basically how we use our piecewise function with a real-world scenario. I hope this helped out. If you have any questions, go ahead and leave a comment. Give me a thumbs up if you like the video, and don't forget to subscribe. All right, good luck, enjoy, and have fun.